Okay, I'm going to introduce this idea of continuity and discontinuity. And when we're talking about discontinuity, it'll be at a given x value. And continuity is also on a specific domain, meaning there's a certain area of the graph, or for some functions, it's the entire graph. So let's talk about continuity first. Remember what I said about polynomials? Polynomials are fully continuous. There's nothing that's going to stop that parabola from continuing to go up, and as it's going up, it's also going to the left and right. And for this cubic, it's going to continue going up and down, and even though it's gradual, it's going to the right and it's going to the left. So polynomials are fully continuous. All right, then we have even roots. So square root, fourth root, sixth root, you get the idea. From their starting point, wherever that is, and whichever direction they go, because sometimes, remember, an even root can look like this, it can look like that, it can look like that. Most of the time it's going to look like this, but it's fully continuous on the part where there is a graph. It doesn't cover the entire coordinate plane left and right, but at whatever starting point, whatever direction it's headed, that part is fully continuous. And then there are odd roots. So cube root, fifth root, seventh root, you get the idea? Those are fully continuous. They'll be a little bit more curvy if it's a fifth root or seventh root, but fully continuous. So these are all continuous graphs. There are no breaks. So when there's no break in a graph on a certain domain, that function or that graph is called continuous, and it has continuity. All right, now there's discontinuity. And usually we're saying look at a specific x value for that. But discontinuity happens when there's a disconnect. There's a vertical asymptote that forces that graph. So for an example, this graph starts here and it gets really, really close to the y-axis, and then it has to turn really sharply. Then it starts over here, it's very sharp, and then it's very steep, and then it curves, and it goes off into positive infinity. But that asymptote right there causes a break in the continuousness of the graph. So it's discontinuous in this case where x is equal to 0. It is discontinuous. All right, so same with this example, except for this is a rational graph. Still the same thing, where x is equal to 0, that function or that graph is discontinuous because the asymptote forces the break. Then there's another type of discontinuity, and this is called, well, I'll get back to that later, but there are some trig functions that are just kind of minding their own business, going along, and all of a sudden there's this rapid vibrating, and it doesn't stop, just vibrates, 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 and then it's kind of goes back to the normal graph. Well, right there where it is vibrating rapidly, it's so rapid that you can't even get it to pause long enough to find a height. That is a form of discontinuity. In fact, I'm going to do that in red because now I've covered that up. Is where it is moving up and down, up and down, up and down so rapidly that you can't find the height. All right, so that's the general idea of continuity versus discontinuity. And then we're going to talk, about the 4 types of discontinuity in the next video. All right, that's it.